So we're going to continue using the zero product property to solve equations. In the first 21 problems, the problems were set up perfectly to use the zero product property, meaning one side of the equation had a zero and the other side was factored. That's the best case situation. If you have a problem that's presented one side factor, the other side zero, then you can just jump straight into setting the factors equal to zero to get your solutions. The next group of problems have the one side zero, but they don't have the other side factored. And so we're going to need to factor first, and then set each factor equal to zero to get my answers. We're going to set each factor equal to zero and solve for the unknown. And I didn't think I needed to do any theory. We already know how to factor. We know how to apply the zero product property if one side is factored and the other side is zero. So I'm just going to jump into this and start with 22. So my first step in 22 is to factor. And because there's not a number in front of the square term, I'm able to sight factor this. There's no need to rewrite this as four terms and factor by grouping if I know the appropriate firsts and the lasts. Firsts come without a lot of thought. I'm just going to split the x squared evenly into the first positions. And then I'm going to use my template. My template says if the original problem has a negative sign first and a positive sign second, that I'm shooting for double negative numbers. And in this particular problem, I'm looking for double negative numbers that multiply to 6 and add to negative 5. And I know what those are. I know that negative 2 times negative 3, it's double negative, multiplies to 6, and negative 2 plus negative 3, double negative, and add to negative 5. So I'm going to fill in my lasts, just writing down the numbers that do what they need to do. Now that I have the problem factored, I'm going to set the factors equal to 0 and manually do the algebra to solve for x. But if you can do something in your head, do it in your head. Setting x, the factor of x minus 2 equal to 0 and adding 2 to both sides seems like silly algebra to show. It's algebra that you should be able to do in your head. Similarly, setting the factor of x minus 3 equal to 0, showing plus 3 to get the x isolated also seems silly. Those I claim are my answers. Anytime I solve a problem that has an equal sign, I always can check. And I have to check the numbers separately. So if I wanted to check the x equal to 2, I'd need to change the x in the original problem to 2 and make sure that when I do my checking, my left and my right side match. Since my right side's already 0, I best get 0 when I put 2 in for x. If I don't get 0, if I get anything other than 0, then 2 is not a solution. But it works. For instance, if for some reason I thought negative 2 was an answer because I forgot to change the sign or choked my algebra, if I plugged negative 2 in for x, I'd get 20 for the algebra of substituting in for x on the left-hand side. That's not a good answer because that wouldn't match the 0 on the right-hand side. Next, I'm going to check 3 for x. And just use this mouse feature and the delete key to speed check. Just like when I plug 2 in, I get 0 equal to 0. I get 0 equal to 0 when I plug 3 in, so I know that's a good solution as well. I'm trying to just maybe do 5 or 6 problems on this part of the video. specifically because my videos get so long, and I don't think I need to do as many problems in this part because there really isn't anything new. It's all stuff we've already done. In 24, I can also cite factor. In 24, because the original problem has a plus and a minus, my template says I'm looking for positive and negative numbers. Larger number gets the plus sign. And specifically, I need my numbers to do two things. They need to multiply to this -7, and they need to add to that +6. Of course, one of the numbers has to be positive, the other has to be negative, and the larger number needs to be positive. And for me, that's easy as well. 7 and -1 fit the criteria. One positive, one negative, larger number positive. They multiply to -7, and if you add 7 and -1, you get -6. All of this, it'd be best if you could do it in your head. You shouldn't probably write down anything. If I was solving problem 24, my first step of my algebra would be this, cite factoring. I'll take the x squared and I'll split it evenly between my parentheses. And in one of my parentheses, I'm going to put a +7. The other, I'm going to put a -1. And I'm going to cite solve these. The x plus 7 factor, if I set it equal to 0, I'd go x plus 7 equal to 0, -7 minus 7, I'd get x equal to -7. If I set the x minus 1 factor equal to 0 and did +1 + 1, I'd get x equal to 1. Let me check these, but not write down anything about the checking. So if I wanted to check the -7, I'd go to the original problem, and inside the parentheses, where the x was, I'd create a parentheses, and inside the parentheses, I'd put the -7 that I think is my answer. So I'd make it the quantity -7 squared plus 6 times -7 minus 7. And the only time I could put a check mark to say this is right is if the right and the left side match. Since the right side is 0, I need to get 0, and I do this. Works perfectly here. Now let me check the 1 by just going back into the problem, changing my -7 to a +1. And I get the same good checking. So that feels good. Of the next 4 problems, they all have the same factoring skill, and 2 of them have a harder solving skill than the others, so I'm going to do the ones that are a little bit harder. If I look at 26, 27, 28, and 29, they're all difference of squares. They're all going to factor into 2 essentially identical parentheses, one with a plus sign, one with a minus sign. I square root the coefficients, square root the constants, divide the exponents by 2. 28 and 29 look harder than 26 and 27. I'm going to skip 26 and 27, and I'm going to factor 28 and solve it. In the world of 28, to get it solved, I'm going to get it factored by creating 2 essentially identical parentheses, except one has a plus, the other has a minus. And in my first position in each parentheses, to the left of the sign, to figure out what goes there, I square root the 25, and I divide the exponent of the x by 2. That's going to tell me preceding my signs in each parentheses, I'm going to get a 5x. After the signs in each parentheses, to figure out what goes there, I'll square root the 16, and it will give me a 4. I could even cite factor these, cite solve these, and if you can cite solve, don't show this algebra. This algebra, just, if you need it, show it. But if you can do this in your head, do it in your head. It's going to save you some time. And the higher you get in math, the more time saving gets to be an issue. In our class, I never try to make the tests anything that you have to rush through. And if you're slow doing algebra, shouldn't be any worries about finishing my tests. But boy, if you get up into a calculus class, if you can't get efficient solving problems and doing some stuff in your head, you could have a hard time finishing some tests. And then all of a sudden you get penalized. Your grade doesn't really reflect what you know. It reflects what you know and how fast you can do the work. So, and at the beginning here, it can't hurt to start doing little basic algebra in your head. I didn't talk through any of this algebra. For the 5x plus 4, I'd minus 4 from both sides and then divided both sides by 5. For the 5x minus 4, when I set it equal to 0, I added 4 to both sides and then divided both sides by 5. Usually in these difference of square problems, when we solve, we get opposites for our answers. Same number, opposite signs. And normally when that's the case, we write the answer with a plus or minus sign. Let me check, because it's important to check, but lazy check. I'm going to enter the negative 4/5. I'm going to replace the x with negative 4/5 in the original problem by doing 25, and then put the negative 4/5 in a parentheses with an exponent of 2 outside of it, and then minus 16. So this, what's on the screen, is exactly what I get if I change that x to negative 4/5. The negative sign, I put it in front of the fraction, but I could have put it in the numerator of the fraction. That wouldn't have mattered. What's going to matter is when I hit equals, if I don't get 0. If I don't get 0, I have a mistake in my work. If I do get 0, because the right side is 0, my answer is correct. Got 0, so I checked the negative 4/5 properly. Now let me go back and check the positive 4/5 by just deleting the negative sign and making sure I get that same 0. And that comes out perfect. So I've done my work, I've checked my answers. I'm going to try to group these into 4 and pick the problem that I think that is the hardest, just to keep the video at a reasonable length. And of the 4 problems I see, 33 looks the hardest. I don't really want to do all your odd problems, but I'll do this one for you. So I'm going to skip 30, 31, and 32. They all are structured the same way. They all have a trinomial set equal to 0, and there's a number in front of the square term. When there's a number in front of the square term, I'm going to rewrite it as 4 terms, group to factor it. So in the world of problem 33, I need to get 3x squared minus 5x minus 2 factored, and it's best when you're using grouping factoring and then setting the factors equal to 0 after you group factor. It's best to factor off to the side to keep the work easier to follow. So my first step in my grouping factoring would be to multiply the 3 and the negative 2. That gives me the target number that I need to multiply to. Peek at my template. My template says if the original problem has a minus and minus, that I need a plus and a minus, and the small number gets the plus. So the numbers that I need to think about, the numbers that multiply to negative 6, small number plus big number minus, are 1 and negative 6 and 2 and negative 3. That's what my template allows me to know. It helps me figure out the numbers that multiply to the number that we need to multiply to. Still need to work with this negative 5x. From these the 2 pairs of factors I have here, I need to find a pair that add to negative 5. And that's the 1 and the negative 6, because 1 plus negative 6, when you're adding them because they have opposite signs, you subtract and take the sign of the larger. So now I know how I can get my problem written with 4 terms, because I know how to rewrite the negative 5x. I'm going to rewrite it with a 1x and a minus 6x. And anytime I'm grouping factoring, if I have a choice of writing a negative second or writing a negative first, I'm going to write the negative first. It just makes my factoring easier. So finally, with all this preliminary work, now I have the tools or the knowledge of how to take the original problem and how to break it into a problem that has 4 terms so that I could factor by grouping. So I split the problem into halves. From the first half, I'm going to factor out a 3x and be left with an x minus 2. The second pair doesn't have a common factor, so I'll factor out a 1 and be left with another x minus 2. So that original trinomial can be factored into x minus 2 times 3x plus 1, and that's what I'll put in my real work. Keeping the grouping factoring off to the side just makes it a lot cleaner to look at. The x minus 2 factor, I'm going to sight solve and get an answer of 2. If you want to, the 3x plus 1 factor, you can sight solve and get an answer of 1/3, negative 1/3, or you can by hand solve, set the 3x plus 1 equal to 0, minus 1 from each side, and get 3x equals to negative 1, and then divide both sides by 3 and get the negative 1/3. Now I'm going to check each. Check the 2 first. Go 3 times the quantity 2 squared minus 5 times 2 minus 2, and when I hit equals I better get 0 because I'm plugging the number into the left hand side, and in order for an answer to be correct, the left and the right side need to match, and the right side's already 0. So it works perfectly there. Now let me check the negative 1/3 by changing the 2's, or changing the x's equivalently in this case, to negative 1/3. And you'll notice that this time, instead of putting the negative in front of the fraction, I put it in the numerator, just to show you that it doesn't matter where you put it. Equally good things happen. I get 0 equal to 0 for that as well. Um, 36 and 37 look a little harder than 35 and 34, but I have so many problems that the grouping factoring has the number 6 that comes up that I'm going to do 34 just because I want to show a different number other than 6. So I'm going to do 34. It's no different than 35, 36, and 37 that I'm going to skip over. These are all structured the same. The factoring that needs to be done is going to be grouping factoring, because, whoop, not 37, 37 is sight factoring. I didn't even realize I snuck such an easy problem in there. 37, baby food. You should sight factor that and not have to worry about grouping. 34, 35, and 36, I need to group factor because the number in front of the square term. So again, just to keep the video a reasonable length, I'm going to do like every 4th problem or every other even problem. So I'm going to try now to factor this 5x squared plus 12x plus 4. I start off by multiplying the 5 and the 4, and I get 20. My template says if the signs are plus and plus, I'm looking for double positive numbers. Specifically, I'm looking for double positive numbers that multiply to the number 20 that I just computed, and in addition to that, they add to the number 12. And to save time, I'm just going to write those down. 10 times 2 are double positive. They multiply to 20. 10 and 2, double positive. They add to 12. So that gives me the ability or the knowledge of how to rewrite the 12x. And there isn't a good number to plug first. It doesn't matter if I said 10x plus 2x or 2x plus 10x. When they're both positive, it absolutely doesn't matter the order that you write the separation in. So I am factoring 5x squared plus 12x plus 4, and I'm going to rewrite my problem as 5x squared plus 10x plus 4 plus 2x plus 4. just taking this 12x and splitting it, leaving the rest of the problem the same. Put my vertical line in, factor each half. On the left half, I'm going to factor out a 5x and be left with an x plus 2. After the plus sign, I'm going to factor out a 2 and be left with an x plus 2. And that's going to give me x plus 2 times 5x plus 2. All this side work is just to keep my main work clean. Honestly, I factor in my head, so all this side work that I showed you, I wouldn't even have anything written down because, Mrs. Emmons in 1978 taught me how to factor in my head and never forgot. But factoring in your head, it's just because I do numbers really well, it was a skill that was learnable. It's not a skill that is that important, and boy, it's a skill that takes a lot to learn, especially if you just can't see numbers in your head. Now that I have it factored, I'm getting the answer that each factor produces. For the x plus 2 factor, I can just sight solve it and get x equal to negative 2. For the 5x plus 2 factor, I could probably sight solve it and get negative 2/5, but I showed the algebra on the screen just in case you need that. And now I'm going to check each by going into the very original problem and changing the x's to each of the potential solutions. So I'm going to go to the 5x squared plus 12x minus 4 and first change both x's to negative 2. Put them on my calculator and make sure when I hit equals I get 0, because I'm making the left side match the right side and the right side's already 0. Since the negative 2 worked, I'll do the same thing with the negative 2/5. Change each of the x's in the original problem to a negative 2 to a negative 2/5, and make sure that when you hit equals you get 0, which means the left and the right side match perfectly. Maybe just one more. We're getting to the 25-minute range, and of the next 4 problems, 38 has way easy factoring. That's not worthy of doing. And I felt like we did a problem like 39 and 40. So let's do 41 together. It has the theme of when I multiply, I get a negative 6. There's a bunch of those in this grouping. So last problem for this part of the video, we'll do 41. That wants me to solve 3y squared plus 5y minus 2 equals to 0. I'm going to do my factoring on the side. I'm going to multiply the 3 and the negative 2 to get negative 6. My template says if the original problem has a plus and a minus, that I'm looking for plus minus numbers, larger number plus. And I know that they need to multiply to negative 6. So my template combined with the multiplication tells me these are the potential numbers to break up the 5y, but only one of them is going to work. And I'm trying to find a pair that add to positive 5 to know specifically how to break up the 5y. And the 6 and the negative 1 will do that just fine. So I'm going to rewrite the 5y as negative 1y plus 6y. Anytime I'm going to rewrite to group and I have one positive and one negative, I always do the negative first and the positive second, because it makes the factoring for me easier to do. So I clumsily rewrote the negative 5y so that my problem now has 4 terms. I start choking on the sign there. I'm going to factor by grouping, so I split the 4 terms into groups of 2. And from each group of 2, I'm going to do my common factor factoring. From the first pair, I factor out a y. From the second pair, I factor out a 2. and then I finish up my grouping factoring. Again, all this side work. And back to the body of my problem. I'm going to sight factor each, sight solve each. This 3y minus 1, I'd add 1 to both sides and get 3y equal to 1. Then I divide by 3 and get y equal to 1/3. So instead of going 3y minus 1 equals 0, plus 1 gives me 3y equals to 1, divide by 3, get y equal to 1/3. I solved it in my head. And similarly, I'm going to solve the y plus 2 equal to 0 in my head. And now check each. First answer I need to check is 3 parentheses fraction 1/3 parentheses squared plus 5 parentheses fraction 1/3 minus 2. And when I hit equals, I have to get 0 because the right side is already 0, which I do, so the 1/3 checks. Now I'm going to back up, delete everything inside the parentheses, and change the contents of each parentheses to a -2, which is the second answer I'm checking. And because I get 0, I know that answer is correct as well. So we're going to do a part 3, then a part 4. The part 3 is going to feel remarkably similar to this, other than there's just going to be one extra step in the factoring. There's going to be common factors that need to be factored out before we get into this phase.